on logarithms. We're going to take you just on the basics of logs and give you some examples and then give you an exercise and take you through the section step by step. Alright, so let's go. So we're looking at logarithms, and in short, in maths we just call it logs. So from now on we're just going to talk about logs. We're not going to use the word logarithms. Alright, now first we must understand where logarithms come from. So let's look at what we call index form. It comes from writing numbers in index form. Let us take a thing like 2 cubed is equal to 8. So this is in index form. Now the same thing can be written in log form. So we say that the log of 8 to the base 2 is equal to 3. Now note the difference, right? You got 2 cubed is equal to 8. So we say log of 8 to the base 2 is equal to 3. Now what happens here is, here the base was large, but here the base is written small. Here the index was small, but here the index is written in normal size. Let's take another example. Number 2, 3 cubed is equal to 27. So we say that the log of 27 to the base 3 is equal to 3. So if I put in some letters here, if I say a to the m is equal to n, then you will say, well, the log of n to the base a is equal to m. Let's do another example. Let's suppose we had x to the y is equal to z. Then you will say the log of z to the base x is equal to y. So that's the first lesson you will have, that if you're given something in index form, you must be able to write it in log form. Alright, so I'm going to give you a little exercise now where I will give you the questions in index form and you must be able to write it in log form. Alright, here we have exercise 1. You are required to write the following in log form. Number 1, 2 to the 5 is equal to 32. Number 2, 10 cubed is equal to 1000. 3, 36 is equal to 6 squared. 4, a to the m is equal to b. 5, a to the b is equal to c. Alright, now what you must do, stop the DVD and try these examples and return to us to mark it. Right, welcome back. So you tried them and hopefully you got them all right. So the answer for number 1 would be the log of 32. You see the number is 32 to the base 2. The base is 2 is equal to 5. Number 2, the log of 1000. The number is 1000. Log of 1000 to the base 10 is equal to 3. Number 3. Now, in this question, we just wrote it the other way. 36 is equal to 6 squared, which you agree is correct. So, 36 is the number. So, the log of 36 to the base 6 is equal to 2. In fact, if you write all your questions like this, life becomes easier, because then you will write it as you speak, that the log of 36 to the base 6 is equal to 2. The log of 36 to the base 6 is equal to 2. So, if I follow the advice that I got in this question here, then I can rewrite this question as b is equal to a to the m. I can rewrite this as b is equal to a to the m. Now it's easier to write the answer. Log of b to the base a is equal to m. And finally, number 5, the log of c to the base a is equal to b. Now, note carefully that we have used letters in these questions over here. We have letters or variables. So, you must remember that in logs, the base and the numbers must be positive and not equal to 1. So what we are saying is that, look, the number and the base must be positive and not equal to 1. The number and the base must be positive but not equal to 1. So when dealing with letters, that is a restriction. The indices can be anything, or the logs can be positive or negative. The logs itself can be positive or negative, right? We'll do a few examples just now to show you how it works. All right, so let's move on. Okay, now what we're going to do, we're going to show you something special about logs. In other words, something that is understood in logs. Understood means it is there, but it is not written. So in logs, if the base is 10, for example, the log of 1000 is equal to 3. If you look at this, the base is not written. Well, the truth is the base is understood. So log of 1000, this statement can be rewritten as log of 1000 to the base 10 is equal to 3. You see, at that level there, the base was understood, the base was not written. So in logs, the base 10 is understood. In logs, base 10 is understood. So, if I gave you 10 to the 4 is equal to 1, 2, 3, 4, and I asked you to write this in log form, your answer will be log of 1, 2, 3, 4 to the base 10 is equal to 4. That will be correct. Or you can use your knowledge about understood and say that the log of 10,000 is 4. In this case, you have left out, right? In the second case, you have left out the base. You have left out the base because in logs, the base 10 is understood. If the base is any other number, it has to be written. But if the base is 10, you can leave it out. So the base 10 in logs is understood. It's not written here, it's understood. If this was my question, that would be my answer, which is right. And even that will be right because there I can choose to leave it out because the base 10 is understood. Alright, so that's the next important thing we have to learn in logs. Right, let's move on to now what I'm going to do. In the next section, I'm going to give you an exercise where the sentences are written in log form and you're going to write it in index form. So that's where we're moving next. I'm going to give you some sentences written in log form and you will write it in index form. Let's take an example. I'm going to give you things in log form. This is an example. For example, log of 64 to the base 8 is equal to 2. I'm giving you a log form. I need you to write it in index form. Now it's very important to be able to do this. From log form you must be able to go to index form. From index form you must be able to come to log form. So if I have to rewrite this, it will mean that 64 is equal to 8 squared. 64 is equal to 8 squared. Or if you like to help yourself, you can do it. You can do a little curve like that. That might help you to think clearly. 64 is equal to 8 squared. Let me just do another example. Example 2. The log of quarter to the base 4 is equal to minus 1. The log of quarter to the base 4 is equal to minus 1. So, if you're going to write this in index form, you're going to say, well, quarter is equal to 4 to the minus 1. So you can see now in this example I'm showing you that the logs can be positive or negative. The logs can be positive or negative, right? Logs can be positive or negative. And I'm also showing you how to rewrite from log form to index form. From log form to index form. Alright, let's just do one more example. Let's put some letters in it. Let's say the log of A to the base B is equal to C. When you're studying logs or when you're studying maths at any time, always work with numbers and then move on to letters. You start with numbers for good understanding and then you move on to letters. So once again, if I want to convert this, then to help me I can just do a little arrow like that. So A is equal to B to the C. Alright, so now there you are. These are all in log form and there you have written them in index form. You must be able to write from log form to index form. You must be able to come back from index form to log form. Alright, I'm going to give you now a little exercise to do and I'm going to call it exercise 2, and this time you have to write the following in index form. Write the following in index form. And don't forget that sometimes the bases will not be written because the base 10 is understood. So let's see. Say log of 125 to the base 5 is equal to 3. Number 2, the log of 100 is equal to 2. Number 3, the log of 1/8 to the base 2 is equal to minus 3. Number 4, the log of 50 is equal to x. Number 5, the log of 75 is equal to y. So here you have 5 examples and you are required to rewrite them in index form. Right? So you can take them down, stop the DVD, work it out, and then come back to check the answers. Right? Enjoy them. will be to do that. So the log, so 125 is equal to 5 cubed. Number 2. Now number 2, I've got a problem in number 2. The base is not written. Well, there's no base written here. Well, therefore the base is understood to be 10. The base was not written, so it's understood to be 10. So the base is 10, right? So I wrote it down now, so I will now use it. 100 is equal to 10 squared. Remember that base was not written, therefore it is understood to be 10. Number 3. Well, the base is 2, then just to help me I will do that. So 1 over 8 is equal to 2 to the minus 3. Number 4. Once again now, let's just separate it here to make our life easy. Now when we look at number 4, again the base is not written. So if the base is not written, it is understood to be 10. So I will just fill it in here now. I'm now filling the base in. It's understood to be 10. So the 10 will go there. So I will say that the answer is 50 is equal to 10 to the x. And number 5, once again the base is not written, therefore the base is understood to be 10. I'm now writing it in, and then to help me I will do that and say that 75 is equal to 10 to the index y. Alright, so those were the answers, and in this exercise you had to recall that if the base is not written there, it is understood to be 10. Right. There's no need to make these marks, but I've just made them just to show you how it is done and how we arrived at the answer. Alright, we are going to move on from here now to what we call the 4 basic laws of logs. We're going to move on to the 4 basic laws of logs. That's what will be next. Okay, so we're going to write down law 1 first. And law 1 states that the log of a to the base m plus the log of b to the base m is equal to log of ab to the base m. Now what is important to understand in this law is this law works provided the bases are exactly the same. Both the bases are m and m, therefore the law can apply. It is log AB. AB obviously means A times B. So let's do an example. Suppose you had a question like this: log of 25 to the base 10 plus log of 4 to the base 10. Then firstly, when you look at it, the bases are exactly the same. Therefore, and this represents A, that represents B. So the law says you must multiply A times B. So if this is A and that is B, then we have to multiply these two numbers. So the answer will be log of 25 times 4 and the base is 10. And if I simplify that, it becomes log of 100 to the base 10. I've chosen to write down the base this time. Right, let's do another example. So we'll call this example, for example, number 1. Number 2, log of 8 to the base 2 plus log of 4 to the base 2 plus log of 5 to the base 2 is equal to. Now, although the law only shows you 2 numbers there, you can have more than 2 numbers, provided the base is exactly the same. If there's 2 numbers, you multiply the 2 numbers. If there's 3 numbers, you multiply the 3 numbers. So in this case, the answer will be log of 8 times 4 times 5. 8 times 4 times 5, all to the base 2. Don't leave out the base must be written because it is 2. If it was 10, you can leave it out. But if it is not 10, it must be written. And that simplifies to log of 8 5 41, 60 to the base 2. So that now simplifies to log of 160 to the base 2. Alright, so let's do another example. This time we'll introduce some letters. Let's say log of m to the base a plus log of y to the base a is equal to, well, the bases are exactly the same, so it will become log m times y. M times y is my, and the base is a. So that's applying law number 1. Now let's do an example where the law can't work. Suppose you have log of 5 to the base 2 plus log of 4 to the base 3. Well, in this case, the bases are not the same. The bases are different. The law cannot be used, and that will just remain the same. You can't do anything about this for the moment. So this will just remain the same. Only thing I'm going to write here is that the law does not apply in this case because the bases are not the same. For that law to work, the bases must be the same. In this case, the bases are not the same. The law does not apply. I cannot multiply 5 by 4. So for the moment, it will just remain the same. Just leave it like that. You cannot do anything about it. Alright, so I'm going to give you a little exercise now where you can practice law number 1. Alright, so here we are, exercise 3. Let's say number 1, I give you the log of 5 to the base 4 plus log of 10 to the base 4. I want you to simplify this and you will try and do something. Number 2, the log of 4 plus the log of 5 plus the log of 40. Number 3, the log of m to the base a plus the log of n to the base a. Number 4, the log of 5 to the base a plus the log of b to the base a. Alright, here are 4 simple examples. You just apply law number 1 on them as far as possible and do not use a calculator. Alright, so stop the DVD and take these questions down and thereafter work them out and return to mark your work. Alright, so we want to apply law number 1 here, and that law says check if the bases are the same. Yes, the bases are the same. Therefore, you can multiply those two numbers. Just demonstrate. These two numbers can be multiplied. So the final answer is log 5 times 10, 50, and you must indicate the base, which is 4. Number 2, this time the base is not written. So the base is understood to be 10. So it's 10, 10, 10. Bases are the same. You can just multiply the numbers. 4 times 5, 20. 20 times 40 will give you 800. Log 800. 4 times 5, 20. 20 times 40 will give you 800. And the base, I can also leave it out because I can write it like that. Or if I want, I can write log 800 to the base 10. Choice is mine. I can write it or leave it because the base is 10. Right, let's move to number 3. Once again, before I apply the law, I can see a plus sign, so law 1 applies. Are the bases the same? Yes. Therefore, it will be log. Now, these two numbers will be multiplied. M times n is mn. And the base is a. The base must be written. If I look at the next example. Firstly, there's a plus sign. So, law 1 applies. And secondly, the bases are the same. So, two conditions. There's a plus sign and the bases are the same. Therefore, I can just multiply these two. 5 times b is 5b. So it will be log 5b, and I must write down the base, which happens to be a. So the answer for the number 4, log 5b to the base a. Alright, so that was applying law number 1 in logs. And I hope you did get them all right. Now we're going to move on to law number 2. We're moving on to law number... Alright, law number 2 in logs states that log of a to the base m minus, key sign here is minus log of b to the base m is equal to the log of a over b to the base m. Now, watch carefully. Two important things here. Firstly, there's a minus sign. Secondly, the bases are the same. So, according to this law, this can be rewritten as log of a over b. Now, there's your a, there's your b. This will be the numerator and b will be the denominator. Follow that order very carefully. That will be the numerator, that will be the denominator. Always. A will be numerator, b will be denominator. Right, let's do an example. Number 1, log of 200 minus log of 2, base 10, base 10. I'm just writing it down, make it absolutely clear. Firstly, is there a minus sign? Yes. Secondly, are the bases the same? Yes. Therefore, the answer will be log 200. It's divide, you see. 200 divided by 2. So 200 divided by 2. I'm doing it step by step, which is really log of. Now 200 divided by 2 is really log of 100 to the base 10. At the moment, I'm just going to leave the answer like that. Later on, we will teach you how to use the calculator and how to get the answer. Let's do another example, number 2. Log of 32 to the base 2 minus log of 16 to the base 2. Well, two things. Firstly, there's a minus sign and the bases are the same. Therefore, law 2 can be applied. The answer will be log 32 divided by 16. Numerator, denominator to the base 2. And that answer will become log 32 divided by 16 is 2. So it will become log 2 to the base 2. Right, let's look at number 3. Now, students usually make a mistake with a question like this. Firstly, there's a minus sign. Yes. The bases are the same. Yes. Therefore, we can apply the law. So it will be log 4 over 8 Yes, it will be 4 over 8 because the first number is the numerator, the second number is the denominator, and the base is 2. So there's my base 2. Now that will become log of. Now 4 over 8 is actually half. 4 divided into 4 one time, 4 divided to 8 two times. So it becomes log of half to the base 2. So remember, the first number is the numerator and the second number is the denominator, and that simplifies to half. Right, let's do another example. All these are examples. Number 4, suppose I had some letters. Log of x squared to the base a minus log of x to the base a is equal to. Now, firstly, there's a minus sign, yes. Bases are exactly the same, yes. Therefore, the law can apply. So the answer will be log of x squared divided by x to the base a. Now, x squared divided by x. Recall your laws of powers. Subtract the indices, so you get x to the 1. Write down the common base x. 2 minus 1 is 1, and the base is a. So that is number 4. Right? Remember, the first becomes the numerator, the second becomes the denominator. Now, in case you're wondering where this 1 came from, because there's no 1 here, well, that 1 is always understood, you see. Right, let's do another example. Number 5. Log of a to the base x minus log of b to the base x is equal to. For me to apply the law, I'm going to check the bases are exactly the same. Yes. There's a minus sign. Yes. Therefore, the answer will be log of a over b. A over b, and I must write down the base. Alright, so that was some examples showing you how law 2 operates. Alright, next step, I will give you a little exercise on which you can apply. In the exercise, you'll be able to apply the law to some examples, and you will not be able to apply the law to some examples, because if the bases are not the same, then the law cannot be applied. If the law cannot be applied, then you must write the answer, law does not apply. If the law does not apply, you write the answer, law does not apply. Alright, so we're going to move on now and give you a little exercise based on law number 2. Here we have exercise 4, simplify. Let's suppose again. Alright, once again, exercise 4, simplify these examples as far as possible. Alright. Okay, so let's say we gave you log of 32 to the base 2 minus log of 8 to the base 2. Number 2, log of 700 minus log of 7. Number 3, log of m to the 4 to the base a minus log of m to the base a. Number 4, log of 8 to the base 2 minus log of say 125 to the base 5. And number 5, log of x to the base a minus log of y to the base a. Alright, here are 5 little examples that should keep you busy for just 5 minutes. Try them and come back to mark. So let's say here, stop, DVD, take the questions down, work them out, and come back to mark them. Okay, welcome back. Right, number 1. Minus sign, bases are the same, therefore the law applies. Log of 32 divided by 8 to the base 2. And that becomes log of 4 to the base 2. 32 divided by 8 gives you 4. Right, number 2. Let's check. Bases are not written, but the bases are understood to be 10, therefore we can proceed. So the bases are the same, it is understood to be 10. And a minus sign, so it will be log of 700 over 7 to the base 10. That gives you log of 100 to the base 10. Number 3. Minus sign, yes. Bases are the same, yes. Law applies. Log of m to the 4 divided by m. And the base is a. Now, that will become log m to the 4, the 1 is understood, so this becomes m cubed to the a. Now, you'll see that in the section now slowly your laws of indices are creeping in, and you must know that in maths, you must know the previous sections thoroughly for you to enjoy success in the present section. So if you don't know your previous sections, you will be in trouble. So you see, like here, I'm talking about here. There's a power, you're dividing powers, you must know all about powers. Although you're doing logs, you must also know about powers, previous section. So in case you forgot about powers, go back and watch a DVD on powers. Right, let's move on to number 4. Now, have a good look at number 4. See, the base is 2. And here the base is 5. Although we got the minus sign there, the bases are different. Therefore, the law does not apply. Law does not apply. Anytime if you're learning maths, you must learn where the law applies, and you must also learn where the law does not apply. Right, finally, number 5. The bases are the same, yes, and there's a subtraction sign. Therefore, law 2 applies. And we're going to say log x divided by y. So x divided by y. I can't simplify that anymore. And the base is a. The base is a. Alright. So it was x divided by y. I can write it down there. I can't simplify that anymore. It stays the same. And you must write down the base because the base is a. The only time you can leave out the base if it is 10. Alright, so that was law number 2. Next we're going to move on to do law number 3. So shortly I'll present to you law number 3. But at this stage, what I'll advise you to do is switch off the DVD, go and have a walk in the garden, talk to your neighbor, or listen to some music, have a cup of tea, and come back and then learn law number 3. Don't try to learn everything in one go. Learn them a bit by bit. So when you come back after your short break, we'll do law number 3. So let me tell you, take a break. Okay, so it's written over here, so it's legal. You're allowed to take a break now and come back, and then we'll do law number 3. Right, welcome back after your short break. Now we're looking at law number 3, and this law says that the log of m to the n to the base a is equal to n log m to the base a. So if you look, you'll see what happened. See, there's n over here. N is the index. So what has happened? Let's watch. N is the index, m is the base, m is the number, a is the base. The index has been brought to the front. Can you see there? The index has actually been brought to the front. That's why the n is written there now. So, that's law number 3. For our own convenience, we can call this the index law or power law, just to make our life easy. We can call it the index law or the power law, P-O-W-E-R, or we can call it power law, just to make life easy. Right, so let's do some examples. If I had log of 5 cubed to the base 2, then according to that law there, this index will come over to the front here. So it will be rewritten as 3 log 5 to the base 2. That's what law 3 says. It says that you can bring that index right to the front over here. So you get 3 log 5 to the base 2. Let's do another example. Log of a squared to the base b. Well, that index 2 will come to the front. So the answer will be 2 log a to the base b. Let's do another example. Now, there's y. Y is your index. That's your number. That's your base. So the y will come to the front. So that y will actually come over right here. So what will the answer be? Y log x to the base n. Number 4, log of 100 cubed. If you look at number 4, no base written, don't get worried because the base is understood to be 10. So just the 3 comes in the front and that will become 3 log 100. So pretty simple rule, law number 3. So what I'm going to do now is give you a little exercise to practice law number 3. Right. Number 1, the log of 50 squared to the base 5. Number 2, the log of a cubed to the base b. Number 3, the log of 1000 to the 50. Number 4, the log of x to the power a to the base b. Number 5, the log of 64 to the base 2 to the power 3. Right, here are your 5 little examples. Stop the DVD, take them down, try them, and return to see if you got them right. Okay, good. It's like the chicken advert, eh? It's good and nice. Okay, so the 2 will come to the front. The answer will be 2 log 50 to the base 5. Once again, the 3 will come to the front. Answer is 3 log a to the base b. Once again, the 50 comes to the front. Answer will be 50 log 1000. No base written, base is understood to be 10. Number 4, the a comes to the front. So it will be a log x to the base b. And finally, number 5, the 3 will come to the front. So it will be 3 log 64 to the base 2. Well, you should have got 5 out of 5. Very good. Alright, so that was law number 3. 4. Now law number 4 has got a special name and is called change of base. Change of base. So what does the law say? It says that, look, log of x to the base b is equal to log of x all over, watch that line, right from here till there, all over log of b. So now let's see why they call it change of base. Let's study the question. It was log x to base b. The base was b. Now, after you perform change of base on it, this is rewritten as log x all over. It's a long line right from here till there, over log b. So can you see the base is now 10 and 10. In fact, you can make the base anything you like. If you like, you can rewrite this. If you like, log of x to the base b can be written as log of x over log of b, and I can put anything I like here. I can put a and a here. See, there we chose 10. Now we're choosing a. If I take the same one again, log of x to the base b is equal to log of x all over log of b. And I can put 5 here and I can put 5 here. Choice is mine. So when you change base, the new base will depend on you, what you like to make it. Alright, so that's what change of base is. And of course, I've already done some examples for you. I've done 1, 2, I've shown you. Right, let's do another one. Suppose you had log of 8 to the base 2. Now, right now the base is 2. So I can change this base. And if I apply that law there, this will become log 8 all over log 2. So you see the base here was 2. Now I made it to base 10. Right? So let's do one more example. Number 4, log of 125 to the base 5. That will become log of 125 all over log of 5. And if I want to write the base m here and m here, I can do so. Choice is mine, because I can change the base to whatever base I like. So that's what change of base is. So what I'm going to do now, I'm not going to give you an exercise only on law 4. Alright, let me give you an exercise only on law 4 first. Let me give you an exercise only on law 4. Alright, so shortly I'll give you an exercise based on law 4. Right, here we have exercise 6. You are required to change the base in the following. Number 1, log 64 to the base 4. Number 2, log 200. Number 3, log 7 to the base 4. Number 4, log a to the base b. Number 5, log m to the base 3. In all these examples, change base. Alright, so once again, stop the DVD and try these examples and return to us to see that you got them all right. Welcome back, welcome back. Right, so there we are. So this answer will be log 64 all over log 4. Now, I am purposely leaving the base as 10 here. I'll tell you why. See, the base was 4. We've changed the base now, log 64 all over log 4. As far as possible, when it comes to numbers like this, leave the base to 10 like that. Let's do the next one. Log 200. We can't see the base. Obviously the base is understood to be 10. It was there. It's not written, but it's understood. stood. So it will be log 200 all over log 10. Number 3 would be log 7 all over log b. Number 4 will be log a over, remember it's all over, log b. Right? And finally the last one, that will be log m over log b. So I've changed the base in each case, and in fact in all these cases I've made the base 10, right? So that's called change of base, and that was law number 4. So shortly I'm going to move on now to give you an exercise where all the laws are going to be mixed. So even before I do that, what I'll do next is I'll put all the 4 laws together so that you have a summary on logs before you can start